Okay, so the next thing that we have is example number 14. Example number 14, and that is you want to prove that basically this determinant, which is b minus c, b plus c, actually b plus c, a, and here you have b, c plus a, and b, and here you have c and a plus b. This is equal to 4abc. So solution is basically, for example, let delta be this determinant, which is b plus c, a and a, b and c plus a, and b and c and a plus c, a plus b. Now if I apply basically r1 becomes r1 minus r2, r1 minus r2 or minus r3 actually, meaning that r1 minus r2 minus r3, meaning that first you subtract r2 from r1, and then again you subtract whatever remains, you subtract r3 from that. So if you don't understand this step, you can write it as basically in two steps. R1 becomes basically r1 minus r2, and then again r1 becomes basically r1 minus r3. That would be the same thing, of course. But now I will show you that both of these would give you actually the same result. If I do this one on delta becomes basically r1 becomes r1 minus r2 minus r3, which is b plus c minus b minus c, right? And that would be 0, right? So I would get a 0 over here. I would get a 0 over here. And then again over here I would have a minus c plus a minus c, which gives me a minus c minus a minus c, and that gives me basically minus negative 2c. Negative 2c. And this would be basically a minus b minus a plus b, and that gives me a minus b minus a minus b, and that's negative 2b. Negative 2b, right? Now this is if I apply this first rule over here. Now if I apply these in if I apply the same things in two steps, what I will get is basically r1 becomes r1 minus r2, which means that, for example, b plus c minus b, which gives you a c, right? So the first element becomes a c. And then, for example, a minus c plus a gives you a minus c minus a, which gives you negative c. And a minus b would be the third one. And then if I subtract r3 minus r1, I will get, so this is now r1, right? So then c minus c would give me a 0, the first one. Negative c minus c is negative 2c, which is the second one that I got over here. And a minus b minus a plus b is going to give me a minus b minus a minus b, and that gives me my negative 2b, which is what I got here. So these two steps are, I mean, this step is actually these two steps basically done one after the other. So what that means is that now you have 0, negative 2c, negative 2b, and these rows remain unchanged. So b, c plus a, and b, and c, c, and a plus b. And that is now your determinant. So 0, negative 2c, negative 2b, b, c plus a, b, c, c, and ab. Now, what you can do is that expanding along R1, which becomes, because we have a 0 over here most probably, expanding along R1, we have basically, this is 0. So delta becomes 0 times anything is 0, and negative 1 raised to the third power times negative 2c times basically a determinant BBC, and a plus b, which is basically the same thing as b times a plus b times a plus b minus bc, which is ab plus b squared minus bc, which is ab plus b squared minus bc. And over here I have plus negative 1 raised to the fourth power times negative 2b times a determinant, which is basically b, c plus a, c, and c, and that gives me basically bc minus c squared minus ac. bc minus c squared minus ac. Next, what we have is, I think if this is a negative 1, so negative times negative is positive, so you have 2c times a plus b, ab plus b squared minus bc, and this is a, so then you get basically negative 2b times bc minus c squared minus ac. And I suppose if we do this calculation, we should get 4abc, right? So that is 2abc plus 2 times b squared c minus 2 times bc squared minus 2 times b squared c plus 2 times bc squared and plus 2 times abc. So b squared c, you can cancel these two out. bc squared, you can cancel these two out, and you'll be left with 4 times abc, which is equal to your RHS. Okay, so that is that. Now, question number 15. Question number 15, we have, if x, y, z are different, x, y, and z are different, and delta is equal to this determinant x squared 1 plus x cubed, y squared 1 plus y cubed, z squared 1 plus z cubed. And if this determinant is equal to 0, then show that 1 plus x plus 1 plus, then show that 1 plus xyz is equal to 0. So the solution is if I set delta basically is equal to basically this determinant as x squared 1 plus x cubed and y squared 1 plus y cubed and z squared 1 plus z cubed. And if I have this situation, I can write this as basically x. So you see, basically using one of the properties, we said that if you have this matrix, this determinant, you can separate these two, basically these terms, 1 plus x cubed, you can write it 1 plus x cubed in two different determinants, right? So I can write this as basically going column wise. I can write this as x, y, and z, and x squared, y squared, and z squared. And over here I will write a 1, 1, and 1. And then I will add this to the same column, the same two columns here, x squared, y squared, and z squared. And over here I write these basically x cubed, y cubed, and z cubed. Now, so what we have now is I can take you need to basically take an x out from this row, take a y out from this row, and take a z out from this row, and also what you need to do is move these columns a little bit around, meaning that if I apply to this first matrix, column 3 becomes column 2 and column 1 becomes column 2. So if I apply column 3 becomes column 2, column 3 and column 2 are interchanged, and then column 1 becomes column 2, column 1 becomes column 2. What that means is that column 3 comes basically, this column 3 comes over here, and column 2 goes basically in place of column 3. So that means that then you would have this column over here, and you would have this column over here. And if I interchange column 1 and column 2, then that means that the column that is in the middle comes over here to the left, and then this column would go to the middle. Which means that now if I apply this first, this column comes in the middle, and then the column in the middle goes as a result of this goes to the far left. So I can write this as basically this whole column comes over here, 1, 1, 1, and then this goes in the middle, which I will get x, y, and z, and then this in the first place, in the first step, this went to the right, to the far right, to the far right, so that there you have x squared, y squared, and z squared. If I'm not mistaken, yes. 1x squared, 1y squared, and basically 1z squared. And then of course I can write this as -1 whole squared times this determinant, because -1 squared is equal to 1. So you can multiply by anything and nothing happens really. And then I can take an x from this row out, y from this row out, and z from this row out. So x, y, and z. and then there you have basically 1x and x squared. There you will have y, 1 y and y squared, and there you have 1 and z squared. Right, so 1y squared, 1z squared, right? So that means that you have basically, you can write this as basically 1 plus xyz. You can write this as 1 plus xyz, and this would be common between the two terms, so you can write it over here as 1x and x squared and 1y squared and 1z squared. And of course, you know that now, then again, you need to move a couple of things around. So if I use basically R2 becomes R2 minus R1, R2 becomes R2 minus R1, and R3 becomes R3 minus R1, we have, so let's do them step by step. So you have 1 plus xyz, and that times R2 becomes R2 minus R1, which means that actually we can do them, both of them together, meaning that, for example, I can write R1 as it is, x squared, and 1 minus 1 is equal to 0. This becomes y minus x, this becomes y squared minus x squared. And then over here you have R3 becomes R3 minus R1, so you have 1 minus 1, which is equal to 0, z minus x, and here you have z squared minus x squared. And so then you have basically y squared minus x squared can be written as, this is a squared minus b squared, which is the same thing as a minus b times a plus b, right? So if you have y squared minus x squared, you can write it as y minus x times y plus x. So, and then y minus x would be common here, of course. So I can write this as y minus x times y plus x. And then y minus x would be common here, so I can take it out. And also z minus x would be common here as well, because z squared minus x squared would be equal to z minus x times z plus x. So I can write this as z minus x times z plus x. Now, taking out these common factors, taking out y minus x from R2 and z minus x from R3, we have, so this is equal to basically 1 plus xyz times y minus x from here times z minus x from here, and then the determinant becomes basically 1x and x squared, and over here I would have a 0 and 1, and so taking y minus x out, I'll be left with y plus x, and over here I would, taking z minus x out, 0, 1, and z plus x, right? So that is that. And basically expanding along the first column, we have basically 1 plus xyz, y minus x, z minus x, and expanding along the first column, what you would get is basically, you would get basically negative 1 raised to the power, for example, 2 times 1 times this determinant, which is basically 1 y plus x and 1 and z plus x, and then you would have basically, this would be equal to basically z plus x minus y plus x, which would be equal to z plus x minus y minus x, and then that would be z minus y, and these are both 1, so that would be z minus y, and therefore you have now here we know that basically we know that delta now is equal to, we know that delta is equal to 0, and we know that xyz are different. xyz are different. Now we can say that since delta is equal to 0, meaning that this whole thing is delta, this is equal to delta, and x, y, and z are different, and this is equal to 0, of course, delta is equal to 0. We have, so if basically, if z minus y if z minus y, if basically, if I say that, if I say that basically, if I say that basically something is equal to 0, for example, I don't know, whatever, the same thing, basically 1 plus x, y, z times, for example, y minus x times z minus x times z minus y is equal to 0, then the logical conclusion that you could have from this, what you would normally do in, at least in mathematics, in solving equations and that sort of thing, you would say that basically 1 plus x, y, z is equal to 0, or y minus x is equal to 0, or basically z minus x is equal to 0, or z minus y is equal to 0. That's the logical conclusion and you're using the connective or, basically, meaning that whichever one is true, then that's actually the solution of your equation. Now, since we are saying that x, y, z are different, then of course, if these are two different numbers, the difference of them cannot be equal to 0, meaning that, for example, y minus x can be equal to 0, y minus x is equal to 0 if y is not equal to x, if actually y is equal to x, if y is equal to x, meaning that, for example, suppose that y is equal to 2 and x is equal to 2, then y minus x becomes 2 minus 2, which becomes 0. There is no problem there. But if x is not equal to y, then x minus y cannot be equal to 0. That's logically, you can even take this to the other side. X minus y is not equal to 0. You can simply see that here, right? So now since x, y, and z are different, so then you cannot say that y minus x is equal to 0. That doesn't work simply. Or z minus x cannot be equal to 0, or z minus y cannot be equal to 0. Which means that the only thing that we have here to work with is basically 1 plus xyz is equal to 0, and that is basically what we wanted to prove. Okay. Now that was question number 15. Now question number 16, we have that as well. Let's do that as well. Okay, so now let's do question number 16 as well. This is the last question in this part. So question number 16, we want to show that, basically this determinant, which is 1 plus a, 1 and 1, 1 and 1 plus b, 1 and 1 plus b, and we have 1 over here, and 1, 1, and 1 plus c, that is equal to ABC times 1 plus 1 by A plus 1 by B plus 1 by C is equal to ABC times ABC plus BC plus CA plus AB. Okay, so this is again one of those problems where you need to basically use all of the properties that we learned in order to simplify the determinant and then write it in this form. So so here we have let me see, there is something wrong here. Okay, so now the solution here is, of course, it's simple when you look at the solution, but the steps, I don't know if I could really do this on my own, but at any rate the solution is basically as follows. So if you basically taking out factors ABC, factors A, B, and C common from R1, R2, and R3, common from R1, R2, and R3, we have, so what that means is that you want to take from the LHS, you want to take A from the first row, take out A from the first row, take out B from the second row, and take out C from the third row. So that means that basically your LHS is equal to A times B times C, A times B times C, times the determinant. So if I divide if I divide basically 1 plus a, if I want to take out ABC from basically from this, from 1 plus a, I will get meaning that, I'm sorry, if I want to take a out of 1 plus a, I will get 1 by a, taking out from 1 would be 1 by a plus 1. Taking a out of a would be 1, right? And taking out a from 1, that would give me 1 by a, again 1 by a. Taking b out here, I would get 1 by b, and over here basically 1 by b plus 1, and over here taking b out, I would get 1 by b. Taking here c out, I would get 1 by c, and again 1 by c, and 1 by c plus 1, right? So that would be basically the LHS. Now, if I apply basically R1 gives R1 plus R2 plus R3, R1 plus R2 plus R3, we have so R1 changes to basically you have ABC times the determinant, so this plus R2 plus R3, meaning that you have, for example, something like 1 plus A plus 1 plus 1 plus B, 1 over B plus 1 over C. That will give you, well, the same thing really. You get 1 over A plus 1 over B plus 1 over C, and then again over here you will get 1 plus 1 over A, 1 over B, 1 over C, 1 plus 1 over A plus 1 over B plus 1 over C, and over here you will get 1 plus 1 over A plus 1 over B plus 1 over C, 1 over B plus 1 over C, and the rest would be the same, of course. You would have 1 over B here, 1 plus and 1 over B plus 1, 1 over B here, and 1 over C here, 1 over C here, and 1 over C plus 1 here. So that would be basically delta. Yeah, I actually call it delta. And if I take 1 plus 1 over A, 1 over B, 1 over C, if I take this whole thing out, what I will get is basically, I can write this as ABC times, and take this whole thing out because it's common in the first row. I write it as 1 plus 1 over A plus 1 over B plus 1 over C, and write the determinant as basically 1, 1, and 1. And then over here I have 1 over B, I have 1 over B, I have 1 over B, 1 over B plus 1, and 1 over B, and 1 over C, 1 over C, and 1 over C plus 1. Okay, so then now if I apply basically C2 becomes C2 minus C1, C2 minus C1, and C3 becomes C3 minus C1, C3 minus C1, we have basically, so the column 1 remains the same, so that means that I can write basically ABC times 1 plus 1 over A plus 1 over B plus 1 over C, and this column remains the same. I'm doing some transformations on column 2 and column 3. I write this column as it is, 1 over B and 1 over C, and this column becomes C2 minus C1, meaning 1 minus 1 is equal to 0, for example, and basically 1 plus 1 over B minus 1 over B, you will get a 1 over here, and here you'll get a 0. And column 3 becomes column 3 minus column 1, which means that 1 minus 1 is equal to 0. 1 over B minus 1 over B is equal to 0. And 1 plus 1 over C minus 1 over C gives you 1. And, well, now what you can do is you can just expand, I suppose, because you can expand along the first row, for example, expanding along the first row, we have, so if you expand this along the first row, these two are 0, so you don't have to worry about them. The only thing that remains is basically this becomes negative 1 raised to the second power times 1 times this matrix times this determinant, which is basically 1 0 0 1, and that is a 1 and 1, and that is basically 1 minus 0, so that becomes a 1. The whole thing becomes 1. So the value of this determinant is 1, and therefore you can say that this is equal to ABC times 1 plus 1 over A plus 1 over B plus 1 over C, and that is the value of the value which you can of course write as, for example, if you multiply this, you get ABC plus basically BC, for example, plus AC plus AB, right, which is equal to your RHS. Okay, that's basically all that we have here. In the next video, we will talk a little bit about exercise 4.2, and after that we will have area of a triangle. So we will talk about that as well. So I'll see you in the next video, and thank you.